So we've seen writing data to files like we had up here. So this is our code from the very beginning. This is where we have participant data from user input and we write it to a file. Then we read this data from a file and we save it back into an input list and we kind of reproduce the data format that we had above. And then we sorted the data and did some statistics, or prepared some ability for statistics using dictionaries. So we were able to kind of create repeating ages and all that stuff and count how many times an age repeated. And now the last thing that we want to do is maybe just do some very simple statistics with this. So maybe let's just find the maximum value of, well, let's find, so which maximum value do we want to find? Well, we first want to find the maximum age value, so the oldest age that attended the conference. And we also want to find the maximum counter for an age. So like what age group was represented the most. So those are the two things that we want to find. Okay, so how are we going to do this? Well, first we need to create certain variables that we want to save it in. So we'll just create the first variable called oldest, and let's just do this one at a time. So oldest is going to save the oldest age that attended the conference. And so there are different ways that we can do this, but we'll just keep it simple. And since we know that the age is not going to be bigger, or is not going to be smaller than 0, we'll just make oldest equal to 0. So we know there are not going to be any negative ages. I mean, technically the users could have entered negative ages, but we'll just assume they didn't, that everyone entered their correct age. Otherwise, we would have to do an if statement up here to check if the age is negative and stuff, which you can do. It's just adding an extra if statement and continuously asking the user for input using a loop or something. But we're just going to assume they were honest and stuff. So we'll just assume we have all good numbers and everything, which we do. Since we're inputting the data, we do. If you're developing this or if you're creating this for other people to use, maybe you want to also implement if statements to check, did they input right numbers? Is the age, is it bigger than 0, for example? Is everything valid? Those are some things that you may need to keep in mind later. But we won't really worry about that too much here, since we just want to be able to get the examples flowing rather than working on all the kind of outliers. So yeah, we'll just start with the oldest and make that equal to 0, since, well, we know that because we inputted the age, that no age is going to be negative or anything weird. So yeah, so we'll stay with that. And so the first thing that we want to do is we just want to loop through this age, and we just want to pick the oldest age. So what we're going to do is we're going to do a for loop to go through the age dictionary, and we'll just do for, and then we'll just use our temporary variable and we'll call it temp age. So temp age is just going to correspond to a temporary age. You can notice we used it up here already, but it doesn't matter. It's going to get overwritten here, so this isn't going to interfere at all. And so we'll just use this as a completely independent variable. So it's going to be overwritten. It's going to have no connection to up here, except that the name is the same, but we're using it in a different context and everything. So like if you want, you can call it something else. It doesn't really matter, but we'll just call it temp age because it's appropriate, because just a temporary it's just a temporary variable of each element or if each key in age. So we'll do for temp age in age. So we'll be looping through here key by key. And so what we're going to do first is we want to check if this temporary age is bigger than the oldest, and if it is, we want the oldest to be equal to the temporary age. Otherwise, we'll just leave it. So let's check. So let's write it out first, and then let's understand why we're doing it. So let's check first. If temp age is greater than oldest, then, so what are we doing here? We're seeing if the age that we have right here is bigger than the oldest age that we currently have stored. And if that's the case, that means the oldest age that we have stored currently is actually, in fact, not the oldest age. So what will we do? We'll make the oldest be equal to the temp age. It's that simple. So all we're doing is we're just looping through this age dictionary key by key, and so each key is an age, and we're checking if this age is bigger than the oldest age we have stored right now. And if it is, we just update our oldest age by making it equal to this temporary age. And then let's just first print the oldest age. Okay, so let's run our code. We still have the file created from before, so we don't actually need to input all the data. So the file is still there, and we can just use it directly. We'll just open it here in reading format, and then we'll do the processing of splitting it and appending it. And we've got some stripping going on here, and then we'll go through and then we'll create the dictionary like we've done in the last lesson. And so we either create the ages or we add one to the age if it already exists. And then what we're going to do here is we're going to find the oldest age, and then we're going to print it out. So let's see that. So what we print out here is we print the age dictionary that we've created, and we see 24, 25, 21, and 23. And we go through and we see, we see that we found the oldest age. Now something that we can also do, for example, is we can look for the youngest age. So we can go youngest, and let's just keep it simple, and let's say youngest is equal to 100. So like, I mean, there are going to be more intricate ways that you can do this later by choosing like a certain element, for example, but we'll just stick with this. So we'll just have the youngest be equal to this. I mean, if you want to be really sure, then you should actually go through and take one element in here and have that be the youngest. So you should just pick a random element in here or a random key and have that be the youngest value, because it could be that 100 isn't even in your list and everyone is older than 100, which will give you the wrong number. But we're just going to keep it simple here because we don't want to focus on that too much. We want to focus on finding the youngest element. And so you can just use the same loop. So the loop that we use to find the oldest. So we go through age by age, or key by key rather, but each key is an age anyway. And we first check if the age is bigger than the oldest. And if it is, we'll have the oldest be equal to this new temporary age. And then we can also check if our temp age is smaller than the youngest. So just like we did above, but now rather we're seeing if it's smaller than the youngest. And if it is, then our youngest is going to be equal to this temp age. Yeah. So that's all we're doing. We're just first we're seeing if this age is bigger than the oldest, and if it is, we're updating our oldest, and if it's younger than the youngest, we're updating our youngest. And technically, you could put an else if here, because if it's bigger than the oldest, it's not going to be the youngest. But since our numbers are like this, 0 and 100, the first case both will be updated. So we'll just leave this in here as two if statements. But generally, you can use an if and an else if, because your temporary age is either going to be the oldest or older than the oldest, or younger than the youngest. But it's not going to be older than the oldest and younger than the youngest, because that's not possible. Except if we define parameters first, like we did here. But generally, you can always add an else if statement if your parameters are one of the keys in this dictionary. But yeah, so let's just run this. Oh wait, we want to print the youngest in the very end. So print the youngest, or else we won't see anything. And here we go. So we see the oldest age is 25, and we also see that the youngest age is 21. And so let's also have let's also count. So most occurring age, let's count the most occurring age. So we'll do most occurring age is what we're gonna call our variable, and we'll just also have this be equal to 0 right now. I mean, technically, yeah, you could also again pick an element in here, but let's not really do that right now. Let's just focus right now on finding it. We can look at this stuff later in another lesson where it's more relevant, but here we'll just look at the most occurring age, and we'll also create a counter. So this counter will start at 0. And what this counter is going to do is it's going to count how many times each age occurred, or rather, it's going to be equal to this value here. So what we're going to do essentially is we're going to look at each of these values and we're going to make the counter be equal to this value. And if the counter, or for the biggest value that the counter has, the most occurring age is going to have correspondingly. So if, for example, if we go through this dictionary, then the counter is going to take on the value 1 first, and because 1 is bigger than 0, most occurring age is now going to take on the value 24, and then the counter is going to take on the value 2, and since 2 is bigger than 1, the most occurring age is going to be 25, like here, and then counter is going to take on 1, and since 1 is less than 2, the most occurring age is going to stay at 25, so it's not going to change, and the same thing for 23. Since 1 is less than 2, the most occurring age is going to stay at 25, and it's not going to change. So how would we do that? So let's check. So what do we want to check? Well, we want to check if this value here, if this value to the corresponding key is bigger than our counter. So how would we do that? Well, we check if, and now how do we access this value for the key? Well, we go into our age dictionary, and the key we have here as the temp age. So if the value corresponding to the key given by temp age is greater than the counter, then we're going to make the counter be equal to the value corresponding to the key of temp age. So what does this mean? Well, we're going into the age dictionary, and so our temp age is going to take on the values, or rather the keys 24, 25, 21, and 23, and each time we're going to check. So age with the key 24, so if we have, for example, temp age be 24, is actually going to give us this value here. So age and then the key 24 is going to give us 1. So if 1 is greater than 0, then we're going to make a 0 counter equal to age and temp age of 24, which is 1, so here. And then for 25, age of 25 will give us 2, and then we'll check 2 is greater than 1, yes, so we'll make counter equal to age of, and then 25 is going to be in here, which is 2, so counter is going to be equal to 2. And now age of, and now temp age is going to be 21, so age of temp age of, so age of 21 is 1, and is 1 greater than 2? No, so we're not going to go into this. And the same thing for 23, since 1 is not greater than 2, we're not going to go into this either. Now, of course, there could be times where we have, for example, repeating or competing maximum values, such as we could have, for example, two 25-year-olds and two 21-year-olds, and then we wouldn't find all the cases, and you can account for special features, so you can see if the number occurred, and if it did occur, then you can add all these ages to a list, for example. So if 25 and 21 both had 2 people, so if 2 participants were 21 and 2 participants were 25, then for the most occurring age, we wouldn't just have 1 value, but we would have 2, and we could save those in a list, for example. But those are just different ways of dealing with data. But well, right now we don't have to deal with that, so we can just kind of stick with an integer. But otherwise, if we have, for example, 2 most occurring ages, we would have to have a list, and we would append both of these ages to the list. And then we would check not greater, but we could also check greater than and equal to. I mean, we can also do that now. So, and then if we check greater than and equal to, then we could also append it to a list. But like, for example, for iData right now, it's not going to make that big of a difference. I mean, we're also kind of cheating because we know our data. So if you kind of went in blind and you didn't know your data, then you should check greater than or equal to, and you should still do this, and then you should have the most occurring age be a list rather than just an integer, and every time you go in here, you should append to the most occurring age rather than making it equal to. So that's the last thing we're going to do. We're going to make the most occurring age be equal to the temp age. So that's, the temp age is just the key. And so our counter is going to be the value corresponding to the key, or the value corresponding to the age. And our most occurring age is going to be the age corresponding to the biggest value, or the biggest participant count. So let's also print out, and maybe let's do a little bit more fancy printing here, most occurring age is, and then colon, and then we won't add a space here because we're going to add a comma. And this comma is going to let us just put in the most occurring age variable. And even though it's an integer, because we put a comma here, we can just leave it like that, and the print will take care and put it in as a string. And the comma is actually also going to add a space, so we don't need to put a space after the colon here. And then we put in another comma, so we're going to write some more stuff. So the most occurring age is whatever, and then we'll write with, and then we'll end the string here again, and another comma, and now we're going to put counter. So now we're going to put in the counter number, so that's going to tell us how many participants were like that, and the comma is going to take care of making this a string for us, or a word, and the comma is also going to add spaces, and then we'll put in here finally participants. So what this is going to print is it's going to print the most occurring age is, and then a space, and then it's going to print the most occurring age, and then it's going to print with, and then it's going to print the counter or the number, and then participants. So it's going to print something like with most occurring age is number with X many participants. So yeah, let's just run this and see this in action. So we see we've got our age dictionary here. We've got the oldest age is 25. We've got the youngest age as 21, and we've got the most occurring age is 25 with 2 participants. So that's what we have here, and that's what we found with the counter and with the most occurring age. Yeah, so cool. Now we just did some kind of simple statistics or kind of simple analysis of, the most occurring age. If we liked, we could also apply this to the country, for example. And not a lot would change. All we would have to do is we would just pretty much use the same thing as we did here, and we would take the int away maybe, and instead of looking for age, so instead of looking for the -1, we would look for well, let's see if we can. Nah, we can't. So let's print the input list, and then we can see where our country is saved at. So if we run this one more time and just print the input list, then we can see our order is name, country, age. So instead of having -1 here, for example, we could have either -2, which is the second last element, or we could have 1, which is the second element, and well, in this case, the second last element, or the second element. So first element, second element are the same. So the index 0, 1, or index -1, -2. That would both correspond to the age. So if we want, we can actually do that. Maybe we can do that real quick, yeah. So we'll just do this really, really easy, and we're going to take all of our code here, and we're just going to copy this, and we're going to, let's go under the age here, and we're going to paste it. Because our format is going to be so similar, and we want to avoid as much as possible writing code. So because writing code takes time and we want to save time. So if we've done it before, why would we do it again? We'll just take what we have, and we knew how to do it up here, and now we'll just tweak this a little bit to be appropriate. So maybe first let's take out this print statement, and now instead of having an age dictionary, let's have countries. And so now our countries are going to be an empty dictionary. And now we're still going to go through the input list variable by variable. We want to take the integer away here, so we don't want to make this be an int anymore. And so we want to take that away, and then we can also take this comment away. And now, instead of taking the last element, which is the age here, we want to take the second element. So we can either use index 1 or index -2, so 0, 1, or -1, -2. Let's just go with 1, just because it doesn't make a difference. We can use either. And let's maybe just change the variable name. We don't even have to, but let's just do it. Let's call it temp country, and we'll change it here to temp country. So we're changing all of our temp age to temp country here, and we'll change it to temp country here again. And now there's one more thing that we need to take care of, and we don't want to go into the age dictionary again, but we want to use the country. So we want to go country here, and we're going to replace age by country. And now we're going to replace age by country here. And now we're really doing something extremely similar to what we did up here. So up here, what we did is we went through this list one by one, and we looked at the last element, and we added each of these to the age dictionary. And if it's already in there, we increase this value by 1. And now we're doing the exact same thing for the countries. So we're adding it to a country dictionary. And we're adding the country, so we're adding a different value. We're adding the second element rather than the third, or rather than the last. And we're adding it to the country dictionary, like this. And we're using the temp country value rather than the temporary age value. But we're still going to count. So if the country occurred once, we'll create it and give it a value 1. If it occurs more than once, we'll just increase its count. And then let's just print out in the end, and then what we want to write is countries that attended, like this, and then then we can just print the country like this. So this will just print out the countries that attended, and then it's going to print out the country dictionary. So let's just run that once. Oh, so country is not defined. What we actually want to print out is the countries, and here we want the countries, not the country. So we want this up here. I just wrote country by accident, so we want countries, and we have the temp country here. So now it should work. So this here should be all of this. This is all going to be the same. So we're going through the countries. We're checking if our temporary country is inside this country dictionary. If it's not, then we'll add it. If it is, then we'll increase its count by 1. So let's run it. Okay, so we get our first output. This is our input list here. So this is all the data we gathered from the files. Then we print our age. So 1 person, age 24, 2, age 25, 1, age 21, 1, age 23. Now we print out the countries that attended. We have here, so it's only coming on a new line because this is kind of small, but if I drag it out, then we see the countries that attended are 1 from France, then we've got 1 from the country 23, which is Hannah, so Hannah comes from the country 23, which was a little bit of an accident, but oh well, it happens. Then we've got 2 people from Canada, and we've got 1 from the US. So this is kind of the countries now we have in kind of a bit of a perspective. We don't really have the associated names or ages anymore, but now we just kind of have this country data. And then here we get the oldest age, what we did before, the youngest age, and the most occurring age is 25 with 2 participants. And now if we wanted, we could also do this again for the countries. Well, we couldn't really do the oldest or the youngest country, but we could check for the country with the last alphabetical letter or first alphabetical letter or longest name or whatever you want to come up with. So you can do something very similar here, and then you can also look for the most occurring country. So you can use code that's very similar to this if you like, and maybe look at the country statistics a little bit too, and just kind of come up with different criteria for these. But so that's really cool, that we can do all this, that we can kind of do these easy statistics. As you see, when we kind of put it in dictionaries, we lose some of the information that we have from the list here, but we gain additional information, or we don't gain additional information, but we make it easier to read. So we technically already knew that 2 people came from Canada, but it was very hard to pick out from here. And imagine we don't have 5 participants, but we have 100 participants. And so if we only care about the countries, then we can use something like this in a dictionary, and we just discard all the other data, and we just save everything in a dictionary, and we count it, and then we can see which countries attended, We can see how many countries attended by looking at the number of elements. We can see which country has the most participants or attendees, or which participants come from the highest number of participants that come from a certain country, which in this case would be Canada. So that would be the corresponding value here. So this dictionary, for example, makes reading the data and interpreting it a lot easier than just looking at this list. And so they all have their advantages and disadvantages. Here I have all my information, but I can't read it that well. Here I lose a little bit of information, but I make it a lot more readable. And same here. So there are pros and cons to using each, and now you've kind of seen the pros and cons of using lists. So lists are very nice, and they're very good at kind of keeping data stacked together that are relevant, and then we can use them as we like later and maybe put them into more user-friendly and readable formats like we did here with dictionaries or whatever else we may like.